Hello friends, welcome back. In the previous tutorial, we have arranged our vector 2D structure properly, and as I told, we are going to create the remaining functions. Let us take, we are going to create this function, a static function with the name angle, which returns the angle in degrees between from and two vectors. That means it returns the angle between two vectors. Let us click and see what is there inside this. And you can see the syntax of this is it's a public static returns a float value that is going to be an angle. Vector 2, it takes two vectors. One is from vector, another one is to vector. And what it does, it returns the angle in degrees between from and to vectors. Now we are going to perform this. Let us understand. Now if you want to find out the angle between two vectors, we have a small formula. Now let us take, you have a vector A. You can see the vector A is, this is a vector A. It has the value x1, y0, and if you calculate the length of this vector, we know that we are going to get 1. That means it's a normalized vector. Then we have a B vector here, which is looking upward. We have x0, y value 1. If you calculate the magnitude of this, you are going to get 1. So any vector has the magnitude of 1. It is known as a normalized vector or a unit vector. To find out the angle between these vectors, we have a formula. What you need to do, you need to get the normalized vector of A, normalized vector of B. First, you find out the dot product between them. You are going to calculate the dot product. Once you get the dot product, you have to give that result to the cos inverse function. Now what cos inverse function is going to do means, it is going to give you the angle, guys. It is going to give you theta. Now let us check it out. First, we have to find out the dot product A dot B. As they are normalized vectors or unit vectors, it is simple. What we need to do, as we know that if I have to calculate the dot product, I have to say ax dot bx plus ay dot by, right? So what is ax? Ax is 1 multiplied by bx is 0, that is 0, plus ay is 0 multiplied by by is 1. So if you calculate 1 into 0, you are going to get 0, plus 0 into 1, you are going to get 0. So final result you are going to get is 0. So a dot b, you have got 0, my friend. To get the theta, we have to give that to cos inverse. The cos inverse function takes that. So cos inverse of 0 is actually 90 degree, guys. Now let us check it out in calculator. Here I have a calculator. I give 0. Here I say inverse. Here we have cos inverse. If I calculate the cos inverse, you can see that you got the value 90. Now let us check it out, the same thing in code, so that we understand. Let us come back to the Unity, and here we have the vector 2D structure. In this one only we are going to create a static function. So static function I am going to create somewhere over here. I can create public static, and it returns a float, and its name is going to be the angle. It takes two vector 2Ds, vector 2D from, comma, vector 2D 2. So it takes two vectors, my friends. And what it does, it returns back to us, that is cos inverse. Where we have a cos inverse? In a mathf structure. Mathf dot, we have a cos. A cos is arc cosine, so we are going to use a cos. To that we have to give the dot product. So how do we calculate the dot product? We are going to first say vector 2D dot product of, we are going to take the from vector dot normalized, we are going to get the normalized vector of it, that is going to have a unit vector, and 2 dot normalized. we are going to normalize the vectors and we get the result back. Now we know already what normalize does. We know that first the dot product we are going to calculate, and the result we are going to give to a cos, and it returns us back the angle. Now let us check it out so that we get a clear idea. We are having a vector 2D, a vector, which is going to be a new vector 2D, and a vector has 1f, 0f. You can see that here you have a vector 1 and 0, b vector is 0, 1. So b vector we are going to create vector 2D b is equal to new vector 2D, which is 0f, 1f. Now we have two vectors ready. We have from vector a and to vector b. We want to find out the angle from a to b. So what we need to do? We have to use, we are going to create here float angle, and I say here vector 2D dot angle. We are going to use this function angle, and it asks from vector and to vector. So from vector I am going to give a, and to vector I am going to give b. Now a and b will be taken over here. Here we are going to have from vector as 1, 0, and to vector is 0, 1. From vector, if you normalize, you are going to get the same value 1, 0, and to vector, if you normalize, you are going to get the same value, that is 0, 1. And we are going to give it to the dot product. It is going to return 0 back to us. If you want, you can see. First of all, what we can do means we can see instead of using this function, what we do means, let me comment this code. Let me comment and save this and come back over here. We will perform ourselves step by step. Let us, we have a vector and b vector. As we know that if I have to calculate the angle, first I need to get the normalized vector of a and b. So what I do, I just normalize a and b vectors. So what I can do is a dot normalized. What a dot normalized does, let me show that here. The normalized property returns this vector with a magnitude of 1. It returns this vector with a magnitude of 1. It is a read only. It will not change the original vector. So you should remember here a vector will not change. So I say here a is equal to a dot normalized. Now what happens here? It returns the normalized vector and stores in a back. And if you display here debug.log a.x double quotation plus double quotation plus a.y, you are going to get the same values 1f and 0f. Here you get 1, here you get 0. Let us save and come back to Unity and run and check. It's processing. You can see that it is saved. B is not used. That's okay. If I run the code, you should see here 1 and 0. Can you see that? We got 1 and 0. If you calculate the math also, it is same only, because if you take 1 and 0, magnitude will be 1. We know that 1 divided by 1 we get 1, then 0 divided by 1 we get 0, right? Now we can calculate the b vector also. B is equal to b dot normalized is going to give me the resultant vector is going to be same 0 and 1. You can see that also. I can copy this and I can paste over here, and here you can see b dot x and b dot y. And if I save this and come back to Unity, if I run the code, you should see 0, 1, the last output. You can see 0, 1 is the output. So already our vectors are actually normalized, so no problem. Now we have two vectors a and b which are normalized now. That means we have got a vector normalized and b vector normalized. Now we have to find out the dot product. So what I am going to do now, I am going to calculate float r value return value is equal to vector 2d dot product of a comma b. We are going to pass LHS and RHS, left hand side and right hand side. Of course we are going to get R value, and R value must and should be 0. Debug.log, you can see R value. If you display, you will get the 0, because that is what we have calculated. You can see that we are going to get 0, friends. Now let us come back to Unity and run and check. The last output must and should be 0, guys. If I run the code, you can see that it is 0. Now what we need to do, once we have got that, we are going to give this resultant value to the cos inverse. So what I do here, float, this is going to be theta, or the angle, you can say anything, is equal to mathf dot cos inverse. I need a cos function. To that a cos, you can see that you have to pass a float, it returns a float back. So I give here R value, that is going to be given to the a cos, and it gives me theta. So let us check it out. Debug.log, we display theta, theta, theta. And if I save and come back and run and show, I should get here the 90 degree actually. Let us run and check what we actually get. And you can see that you got 1.570796. Actually, we are getting in radians. 1.570796 is actually 90 degree, friends. Let us check it out. If I multiply this theta by mathf dot radians to degrees, or I can directly multiply this here only, we get this one now in degrees. Let us save and come back to Unity. I clear this code, and this time if I run, the last output you are going to find is 90 degree. You can see that you got 90 degree. That is how you can use or calculate. Now what we are going to do this time means we are going to reduce the number of lines of code. So I cut this from here, Control X, I pass to this one, and I cut this one from here, Control X, and I give over here. And I am going to delete this. You can say here vector 2D dot product A dot normalized, comma, B dot normalized. We are going to get here A dot normalized and B dot normalized. What is A dot normalized, guys? We get 1 0, B dot normalized is 0 1, and the dot product, definitely R value will be 0, and that we give here, and it gives us 1.5. We change it to degrees and we get the same output. Now let us save and come back. We should get here 0 and 90. Let us run and check. You can see that we got 0, which is the dot product, and 90 degree is the angle between A and B. Now let us go back, and this time instead of R value, I am going to cut this from here, Control X, and I paste directly over here. I am going to remove these lines also, because our intention is to get the angle. So this time directly we are going to get theta. So this one is cos inverse of dot product of normalized A and normalized B, and the final result that we get, right, is going to be here. This much is going to give us 0, and A cos of 0 is going to give us the angle. We convert that to radians to degrees, and we get the theta. Let us save and come back to Unity and run and check. We should get the 90 degree, guys. You can see that we got 90 degree, right? It is simple. Now this formula that we have, I can say Control X from here, and I can paste in my A cos the angle method, angle. Now angle takes from and to, and here I am going to give from normalized, and here I can say to normalized. So if I save and come back to Unity, this time I am going to say here vector 2D dot, I am going to use the angle method. I give A as a from, B as to. So what happens this time? It is simple. I save this one. So it calls the angle, it passes A and B over here. A is stored in from, B is stored in to. Then from normalized to normalized, we get the dot product between them, and we get the angle, and we convert it to radians to degree, and we get the result back. and you should see, if I save and run, you should get theta as a 90 degree. Let us come back and run and check. You can see that we got the value 90 degree. Right, my friends? I hope you guys are understanding how do you find out the angle between two vectors, what steps you are going to carry, or what actually behind the scene Unity is doing for us. This is really useful. You can use for some other vectors also. Now let us take some more examples so that you get more clear idea. Now let us take, we have a vector which is 200. This is a vector, and we have another vector over here. Let us take like this. We have two vectors, and of course you can say that this is the A vector and this one is the B vector, or you can say A is a from vector, B is a to vector. Now here we are going to say x is 0, y is 200, right? Then here the x is 200, y is 0, and this time also you must and should get the final output as the 90 degree. You can see this graphically only, I can say. But if you want to calculate this, how do you calculate? Now very simple. If you want to do mathematics, like you want to get the normalized vector of A, how do you calculate the normalized vector of A? If you want to calculate the normalized vector A, we know that Ax component I have to take divided by length of A, comma Ay component I have to take divided by length of A. We get the another vector which is actually going to be a normalized vector. Ax is 200, right? 200 divided by, what will be the length of this vector, guys? 100 unit and 200 unit. Of course the length will be 200, so 200 divided by 200, comma this one will be 0 divided by 200. So the unit vector that we are going to get, the A vector we are going to get is 200 by 200 is 1, comma 0 by 200 is 0. That is going to be the A vector's unit vector. Then the B vector also you can find out very easily. You can say B vector is equal to Bx by length of B, comma By by length of B. Simple, right? Here also you can see Bx is 0 divided by length of the B vector is also 200, comma By is 200. Then length of the B vector is 200. So this gives us the B, that is the normalized vector or a unit vector of B is 0, 1. And you can see that one, right? The normalized B vector will be small here and normalized A vector will be small over here. Now once you get the normalized vectors, right, we got the normalized vectors 1, 0, A is 1, 0. You can say here you have 1, 0, and of course the B is going to be 0, 1, 0, 1. Simple. Now we have the normalized vectors of A and B, and of course we can calculate the dot product between A and B. So A vector dot B vector is, again we are going to get 0 only. You can see Ax into Bx plus Ay into By. So what we are going to do here, Ax into Bx is Ax is 1 dot Bx is 0 plus Ay is 0 dot By is 1. We are going to get here 0 plus 0, which is going to be 0, and this we are going to give it to cos inverse, and cos inverse of 0 we know that we are going to get 90, friends. Let us check it out here. We have a vector with the first vector is going to have x 200, y 0, and the B vector is going to have x 0, y 200, 0.0f. Of course here we are going to give that to the angle vector A and B. We send an angle vector takes here A, here B, and A dot normalized will give us 1, 0, B dot normalized will give us 0, 1. Then the dot product will be calculated and it will be given to the A cos and converted to the radians to degrees. Now if I run this code here also, I must and should get the 90 degree. Let us come back and run and check, I should get the output as 90 degree. Let us run and check. You can see that we have got 90 degree, friends. So this is how you can find out the angle. Now let us take it out some other example. Let us take, I have a vector from here to here. This one is minus 100 and 0. And let us take another vector we have which looks something like this. So you can see from here to here it will be 45 degree, right? So you can say from here to here it will be 45, from here to here 90, 90 plus 45, 90 plus 45 is actually equal to 135. So if I calculate the angle between these two vectors, I should get 135 degree. So what will be the x and y over here for a vector? Let us take 100, 100 is the a vector, and b vector is going to be minus 100, 0. That is this one is a vector and this one is the b vector. So let us check it out. We should get 135. Let us write here, a vector is 100, 100, and the b vector we have minus 100 and 0f. Now if I save and come back to Unity and run and check, if I run the code, you can see that we have got 135 degree, guys. So in this tutorial we have understood how to find out the angle between two vectors by using the formula cos inverse of from normalized dot to normalized function, and we have created the angle, and you can see that Unity has the angle method which returns the angle between two vectors, and it is little bit different but almost similar only. We have here, you can see mathf dot a cos of the dot product from normalized to normalized, but they are clamping between minus 1 to 1, that is minus 180 to 180. They are clamping, then they are converting it to degree. Little bit different, but end of the time you are going to get the result as in degrees, so there will be no problem. We have little bit simple code which is easy to understand. So hope you guys have understood how do you find out the angle between two vectors. For this tutorial, this much is enough, guys. Thank you guys, thank you very much. Keep learning, keep coding, remember these formulas. See you in the next tutorial, and we are going to understand some more examples. We see how the dot product and finding the angle between two vectors are useful in some other places. So thank you guys, thank you very much. See you in the next tutorial.